Hey everyone, thanks for joining. Today we are diving into Supabase Row Level Security, what it is, where team usually trips up, and how to protect yourself with continuous realistic testing. If your front end uses NO key or anonymous key and talks to Postgres, RLS become the security wall around your data. When that wall has a gap, even tiny one, a leak would look like perfectly normal traffic, which is why they are so easy to miss. By the end of this video, you will know exactly where to look first and what good looks like. So let's anchor on what RLS actually is. Under the hood, it is Postgres deciding row by row what a caller can read or change. Supabase relies on it heavily for multi-tenant and per-user visibility because the client often talks directly to the database through those reflected REST APIs. That reflection is great for speed, but it means your policy aren't optional, they are the control. Think of RLS as the bouncer with precise rule. Only the right rows get through. With vague rules, anyone with token can see or touch more than they should. The first misconfiguration we see is overtrusting auth UID. It's great for identity, but identity isn't authorization scope. If a policy only check auth UID, a helpful view or clever query can accidentally cross tenant line. The fix is simple: combine identity and tenant. Required that the caller has a user ID and that the row's tenant matches the caller tenant. To better understand this, imagine Alice logs in and thanks to an aggregated dashboard, she suddenly sees Bob's order. Nothing crashes, no error popped up. That's auth UID without tenant boundaries. The second common gap is forgetting right path. The team usually log down select queries and feels that they are done, but update or delete are separate rules. Without explicit policy, especially with check to validate the new values, caller can mutate rows that they don't own. RPCs are where this kind of thing slips in. We only change the function and suddenly a write is bypassing your intended check. Simply put, profile edit flow works perfectly until a user realizes that they can bump another tenant invoice amount just by swapping an ID. So reads looks fine, writes were left open. The third, the edge cases, rows and tenant drift faster if you are not intentional. If a powerful token like service or admin reaches to front end, it bypasses your rows filter entirely. And also RPC with security definer runs as function owner, not the caller, and without explicit tenant and ownership check inside the function in itself, you step outside RLS. Prefer using security invokers. If you must use definer, make sure to use strict check into the body. To help you understand this, a tiny bump count or a like count functions look harmless until it runs as owner and quietly updates every tenant's row. Here are those misconfigurations show up in real world. First, cross data exposure. A harmless viewer join function returns another customer rows. If you won't be able to catch it in QA, you hear about it when a customer exports their data and email has been received with someone else's record. Second, unauthorized update. A like or edit endpoint lets a user change record they don't own because there is no update policy or condition is too broad. Third, silent integrity drift. Definer style RPC functions succeed everywhere, but your monthly total won't match as finance. Dashboard disagree, audit get messy. None of this looks like an attack, it looks like normal API usage. Why these issues are harder to catch? Most teams do functional testing, like I can see my staff, I can complete the flow. That is necessary, but it does not prove the negative. You also need explicit denied test or negative test that show you cannot write or read outside your tenant. Meanwhile, Postgres reflects your schema. Fantastic for builders and also fantastic for attackers because it's trivial to enumerate tables, views, and RPCs. You don't realize were exposed. Imagine the UI test passed with flying colors, but one curl command pulls another tenant table because nobody wrote must not read test. How to make sure that we are safe when it comes to RLS? Two habits would protect you. First, continuous validation. Treat policy like code. Put them in mitigations, review them, add a CI job that spins up a temp DB, seeds two tenants, and run both allow and deny assertions. If a deny test return true, the build fails, and that's a good day. Second, intentional abuse testing. Try mapping REST VI and RPC functions, flip between anonymous and authenticated tokens, and push on write or delete path. If you are not being malicious, you are proving the wall holds. When you find a gap, fix it with a precise policy or move RPC to security invoker and add explicit tenant and user check. My personal rule before shipping: if my tenant user can read tenant B with a single request, that build does not go out. RPC is powerful, but it has to be intentional, meaning identity plus tenant scope. Every operation is covered and no surprise defenders. Add negative test to CI, so the difference between a scare and a headline is one for falling assertion in your pipeline instead of in production. If you want a head start, grab our open source RLS Burp scanner and wire it into your workspace. Discovers the surface, runs allows and deny probes, and explains the why behind each finding. Thanks for hanging out. If you want a quick sanity check on your RLS or a live demo of a scanner, ping us at contact@securifyai.co. The tool is available on GitHub. See you in the next session. Ship fast and ship safe.